Khalid, can you hear me?
Yes, sir.
The first question, KMnO4, is it cold diluted or is it hot acidic? What is the condition, cold or hot?
It's cold.
So what are we going to form? Diol. 2 OH will be attached. Yes or no?
Yes, sir.
Anna? Okay. Now in this is hot acidic. So we'll break this. And this will form ketone plus CH2 will be formed as carbon dioxide. In O3 again we will break this. And we will get a ketone like this. Plus we will get double bond O and CH2. Right? And in this case, there will be addition of water. So we have two carbons, 1 and 2. The carbon with less number of hydrogen will be attached with OH. So we'll get OH here. I hope you have got these problems, yes or no? Hamza and Hiba,
Yes, sir.
please check your answers now. Did you do these problems? Hamza, Hiba?
Yes, sir. Yes, sir. I got all correct.
All correct. Okay. What about this one? Did you do this? Hexane 2,1 plus and methanol?
No, sir. I didn't see this one. I
ये
just did
देखते
the
नहीं
one
आपने
in.
नोट्स नहीं कंप्लीट किए क्या आपने?
No, sir. I just did the one in red marker. The other one I didn't
red
see.
mark. Okay, fine. So the question is that you have hexane 2,1 and methanol, and these are formed by the ozonolysis. These are formed by ozonolysis of an alkene. So he's saying that there is an alkene, and if I treat this with O3 in the first step, and in the second step, if I treat this with zinc in the presence of water, then I am going to get hexane 2,1, 1, 2, 3, 4, 5, and 6. That means I am going to get C double bond O here, and I am going to get methanol. Methanol is hydrogen, carbon, hydrogen, and double bond O. So CHO group with only one carbon. So these are the two molecules that it has been. So I think it is very easy to okay, show the answers once again. Okay, Salman, yeah. Take your time, Salman. Done, Salman? Okay. Fine. So an alkene, I have to find this alkene here. Okay, I have to find this alkene. So how will I find this alkene? So when you have alkene, we just separate it and add double bond O, right? So here also what we will do, we will remove the double bond O and we will attach the carbon which are doubly bonded. So if I do that, then you will be getting hexane like this. There was a double bond here and there will be, so this double bond here, I will attach this carbon atom, right? And the two hydrogens like this. And if I will break it, then I will be getting hexane 2,1 and methanol. So this is my alkene, and let us try to name it. Wait a second, write in a better way. You guys understood this, yes or no? Please tell me. From the product,
Yes,
we
sir.
are going to get alkene, right? Now, we start with this carbon atom. Okay, functional group. Name, IUPAC name. Functional group will be. अरे बाबा जल्दी बोलिए. E. Am I not audible? Hamza, Hiba, please keep your mic on.
Actually, your voice is breaking for me. Like, I guess there's some network lag for me.
Hiba? Acha, Shravya, you tell me. Khalid,
So it will
Salman,
be
for
EN.
everyone. EN. Is it still lagging?
No, sir, not now.
Okay, parent. Okay, no. I was asking if my voice is lagging, Shravya. So in parent, where will I start from? Carbon number A, B, or C? Which terminal? Tell me. Which terminal? A, B, or C? Where should I start from?
A.
A. No. Very good. So how many carbons? 6, right? X. Then we have got one substituent that is in the second carbon. 1, 2, 3, 4, 5, 6. I hope we will start naming with the terminal which is nearest to alkene. So substituent will be 2-methyl. Of 2-methyl hex 1E. This is going to be my alkene. This is going to be my alkene. Okay. Now, in today's class, there is a small topic, polymerization. There is a small topic from polymerization. I'm leaving this. You will complete the notes of polymerization. Okay. There is no reagent, no reaction. There's slight few lines written in the NCERT. You just write that down in your notebook so that if by chance they will ask you, then you can write what is the condition, high temperature and pressure at with catalyst. Okay. So polymerization, you will complete the notes looking at the NCERT. Then your alkenes is complete. This is the last reaction. Okay. This is the last reaction. We'll start with alkynes today. We'll start with alkynes today. Alkynes. Okay, so alkynes, unsaturated hydrocarbons with at least one triple bond, right? At least one triple bond. At least one triple bond. What is the general formula?
Cn H2n minus 2.
2n minus 2. Okay, and the smallest member?
Ethyne.
Ethyne. CH, triple bond, CH, right? Yes or no, guys? Any problem?
No, sir.
No, sir.
I'm asking you a simple question. It may seem look simple, but it is not easy. How many carbons? Or rather, what is the name of? Write the name. Write the name of the fifth member of alkyne. In the homologous series, you have to write the name of fifth member of alkyne. So in the chat, you will tell me. Okay. Fifth member of alkyne. You just tell me how many carbon atoms are there in the fifth member of alkyne. How many carbons are there in the fifth member? No, don't worry about writing the name. Okay, I have got one answer. You understood the question, yes or no? Hamza, Hiba, Khalid, Salman, Sharavya gave the answer. What about you guys? You understood the question? Yes or no? Hamza, did you understand the question? Hamza understood the question. Okay. What about Hiba? Hiba gave the answer, no? How many carbons will be there? हमजा को नहीं है, हिबा को नहीं आया, हमजा to give the answer. Okay. Okay. Yes, Hiba now correct. Yeah, Shravya, now you are correct. So see, the first member is, yeah, see, the first member is going to be C2H2. Second member is going to be C3H4, right?
4.
Yeah, then we will have, the third will have, so you can see the first member has 2 carbon, second member has 3 carbon, third member will have 4 carbon, fourth will have 5 carbon, fifth will have 6 carbon. So the formula will be C6H. How many H?
10.
10. Right? C6H10. Okay, let us also revise a few bit of nomenclature. I'm giving you 2 compounds. You will have to write the name. Write the name of this molecule. Yes, Shravya, correct. By the way, Hamza, Heba, you guys, अब ना ये like थोड़ा दिमाग में ही आप लोग ना उसे functional group identify करके, then you identify the unsaturation and then you choose the parent. Okay. Then you start directly with the parent here when you don't have any substituent, or you start with substituent if you have substituent. थोड़ा सा आप ऐसे like you step up the game. Don't start with functional group, unsaturation, and so on. It is good when you are starting out, but eventually I want you to look at the molecule and have a kind of name in your head. By the way, Hamza, guys, you don't take so much time. What? Why you are guys taking so much time?
Sir, almost done.
Almost done. Almost done sending the answer, or in your notebook you're writing?
Sir, sending the answer.
Achha. ये तो आपने बहुत ही गलत लिख दिया हमजा, है ना, इतना टाइम लगा के भी. What is the functional group, Hamza?
The E,
Saturation.
YN.
Okay. How many terminals are there? टू टर्मिनल्स ना, A and B. आपने क्या ही बकवास लिखा है हमजा, आई एम सो डिसअपॉइंटेड. Where is your mind right now? You see what you have done? Yes, Hamza. Do you see what you have done?
Yes, sir.
है ना, कैसे किया आपने ये? कैसे? हाँ, कैसे किया आपने? हाँ, हमजा कैसे किया आपने ये?
Sir, I took the second carbon instead of
ऐसे
that
नहीं
one.
नहीं, वो टुक हमको पता है क्या आपने किया. I know what
Like
you
I
did.
thought for like the triple bond, and then I took from there.
I know what you did. I'm asking why you did that. टर्मिनल्स है ना, याद रखिए ना. अब लाइक इट विल बी वेरी सैड इफ यू डोंट गेट द राइट नेम्स, है ना. पेंट टू आइन खालिद, पेंट टू आइन. नंबरिंग नहीं किया आपने भाई. छोड़ो, हमारे पे नॉर्मल भेजा, अभी नहीं पढ़ाएंगे आप लोगों को, वरना मेरा मूड ऑफ हो जाएगा. लेट अस स्टार्ट. आई एम गिविंग यू अ क्वेश्चन. We have written this now, the fifth member of alkyne C6H10. You have to write all possible isomers of C6H10 and name it. Okay, this is going to be homework. और इसको हम रेड में कर देते हैं, है ना हमजा? It will be easier for you guys to remember. This is your homework. Okay, one of your homework is, and please see, like you do this, then check it in the NCERT. I think there is one question in the NCERT like this. It is in the examples only, like in text questions that you will have examples, not problems or something. Okay, so check NCERT, you will see this question. Okay, not exactly like this. It will be like, what is the fifth member of alkyne, and what is the molecular formula for that, and write all the possible isomers and their name. So when you do this, after that check in NCERT. But as of now, let us write preparation of alkynes. In preparation of alkynes, we only have to learn two methods of preparation, which are easy methods of preparation. Number one is from calcium carbide. Calcium carbide. So first thing, calcium carbide. First of all, we have to prepare calcium carbide. It is prepared if you have calcium carbonate 3 and you heat this. Then you will get calcium oxide plus carbon dioxide. You take this calcium oxide and you treat this with carbon. Then you will get calcium carbide plus carbon monoxide. Okay. Calcium carbide is C2, sorry, CaC2. Now we have CaC2. You treat this with 2 moles of H2O. And you will get calcium hydroxide plus ethyne, that is C2H2. So you can think of this reaction as you have calcium and you have C2 and you have water, right? You have water. So you have, this is positively charged and this will have 2 negative. That means each carbon will be having 2 negative charge. And water, you have OH and H, you have OH and H. So calcium, it is attracted by OH negative, and the carbide, which has negative charge, it is attracted by the H plus ions, and you get CaOH whole twice and C2H2, Ca whole twice and C2H2. So treatment of calcium carbide with water forms ethane. This is one of the reaction. The other reaction is that we have seen from vicinal dihalides. If you remember the preparation of alkynes, we did preparation of alkynes in this class. Physical properties is preparation यहाँ पे है ना? So see, you see this reaction from vicinal dihalide. Yes or no?
Yes, sir.
Yes, sir.
Yeah, so first of all, we will make this carbon double bond carbon, that is alkene, and we can use one more molecule, that is you can treat this from vicinal dihalides. So you have carbon, single bond carbon, and there are some groups attached, and here you have, let us say, Br, and here you have Br. So you will treat this with, you can treat this with zinc, then you will get calcium, double bond calcium, and there will be some groups attached like this. Okay. Now, next is that you, oh, wait a second. Sorry. If you have vicinal tetrahalide, then you can prepare. As of now, wait a second. Here you will treat this with alcoholic KOH. And alcoholic KOH, what it does, it takes one of this. You should have hydrogen here, one of the hydrogen atoms. Wait a second. Let me write this down. Then I will write the reaction. Sorry for this method. When vicinal dihalides are treated with alcoholic KOH, 1 mole of HBr is eliminated, and on further treatment with NaNH2, it leads to formation of alkane. So we'll have vicinal dihalide CH3 CH with Br and CH2 with Br. So it is going to form one of the bromine atom and one of the carbon, one of the hydrogens will be eliminated. And you will be getting an alkene. You will be getting an alkene here. So the alkene that you will be getting is CH3 CH, and this Br will be intact here. There will be a double bond. So we have eliminated this Br and one of this hydrogen. Okay, and this hydrogen will be eliminated. So Br from one carbon and the hydrogen from the other carbon has been eliminated, and you have got CH2. You've got CH2. Now on further reaction with NaNH2, this again one of the Br and one of the hydrogen will be liberated, and you will get CH3 C triple bond CH, C triple bond CH. So let us suppose you have something like this with Br and one more Br. So wherever the Br is, you will form the triple bond there. You will form the triple bond on those carbon. So in the first step, you will have alcoholic KOH. In the second step, we will have NaNH2. And you will get CH3, single bond C, triple bond C, and CH3. So wherever the Br is present, there will be a triple bond. You can take other halogens also. Let us take chlorine and chlorine. Then you will be forming the same reagents here. Triple bond, 1 carbon, 2 carbon, third carbon, and the fourth carbon at triple bond, and there is a CH2 group. Okay, and why I have written it like this? Because sp hybridized now. So sp hybridized will have straight lines. You don't draw like this. I mean, you can draw because you're in 11th standard, but this is not right because we have drawn a bent structure with some angle, and we know that sp hybridized carbon atom, they will not be bent. Okay, so either you draw it like this, CH3 CH2 CH3 CH2, this will be carbon triple bond carbon and then CH3. You draw it like this, better is this way, no confusion here. Okay, so wherever you have the dihalides, you will remove the halogens and the hydrogens to make it triple bond, Okay, so simple two methods of preparation. One method of preparation is only for ethyne, calcium carbide one, and this vicinal dihalide one is for the other, any other, and also ethyne also, and any other type of alkyne that you want to prepare. Next is the physical properties of alkynes. Physical properties of alkynes. Now, in physical properties, what about okay? In physical properties, boiling point and melting point. So we can say that these are weakly polar and they are immiscible in water, right? These are weakly polar and not soluble in water. If I talk about the boiling points, boiling point and melting point, then boiling point and melting point increases with increase in carbon number, and boiling point and melting point decreases with increase in branching. So general trend that we have seen in the physical properties of hydrocarbons. Now, if it is not soluble in polar, if it is not soluble in polar solvents such as water, it is soluble in, you can write it as soluble in organic solvents, such as ether, hexane, octane. So these are all different organic solids. Okay. Next, the chemical properties. Now, in chemical properties, the most important property of alkynes is the acidic nature of alkynes. The acidic nature of alkynes. Okay.
All up.
You are writing this?
Yes, sir.
I will send you this PDF. You don't have to write.
Okay, sir.
I will send the PDF in the
Yes, sir.
chat, okay, after the class is over. Chemical properties. Okay. Now, in chemical properties, the first is acidic nature of alkynes. Acidic nature of alkynes. Now, if you see alkyne, which is hydrogen, C triple bond C and hydrogen. So these hydrogens, these are acidic hydrogens. They can be liberated. So what is going to happen if I remove one of the hydrogen atoms? We'll have H C triple bond C negative. Okay, C negative. So this is my acid. This is my plus. You will get H plus ion. This is my conjugate base. And we know from equilibrium that the strength of acid, acidic strength, will depend on first two things. How polarized is this bond? For example, if this bond is very polarized, it means there is a high delta negative charge and a high delta positive charge. Then it is very easy to form C from delta negative, and to go to pure negative, it is relatively easy than to go from neutral and neutral, right? So if this bond is very polar, then the breaking of bond is easy. And the next thing is the conjugate base. If the conjugate base is stable, then also this acid is good. This acid is going to be a good acid. So acidic strength is dependent on the bond polarity. So if the polarity is high, that means it is going to be very acidic, and it also depends on the stability of conjugate base, right? Depends on conjugate base. So obviously, now if I look at the bond polarity here, then you can say that this is sp hybridized and this is what hydrogen. So sp hybridized is highly electronegative, and if it is highly electronegative, then it is going to pull much of the electrons from hydrogen and it will make the bond very polar. So since the carbon in alkyne is sp hybridized, the CH bond becomes very polar, and the liberation of H plus is easier. Next is the stability of conjugate base. So the conjugate base CH triple bond C negative has negative charge on sp hybridized carbon. And it is further attached to a sp hybridized carbon, which has minus I effect and stabilizes the negative charge. So both of the conditions are very much fulfilled, that the sp bond is electron withdrawing group through inductive effect, and that is why it is going to stabilize the negative charge. And the negative charge already it is present in the electronegative element, that is sp hybridized carbon atom, which is a electronegative element. Okay, so are these 2 points clear with everyone? Yes or no? Are these 2 points clear with everyone? Yes or no?
Yes, sir.
Okay. Now, please remember one point, that the hydrogen bonded to, you can conclude that hydrogen bonded to triply bonded carbon atom is, or hydrogens bonded are acidic. Okay, not any other hydrogens, only those hydrogens. ऐसा नहीं कि alkyne में आप, if I'm going to write alkyne, CH3 C triple bond CH, then these hydrogens are not acidic, only the hydrogen which is triply bonded to the carbon atom. So if I react this with, let us say, NaNH2, which is a base, NaNH2, very strong base, then this lone pair is going to attack on the hydrogen, and we are going to form CH3 C triple bond C negative. There will be Na positive, and you will get NH3, Okay, so this is the type of reaction that is shown. Now, if I compare the acidic strength Compare acidic strength. So the alkynes are the most acidic because the hydrogens in alkynes, they are bonded to sp hybridized carbon atom. Alkynes are most acidic, followed by alkenes, then followed by alkenes. So CH3 and CH3, all of them will have some or more or less acidic nature, but they don't relatively so acid-base reactions. Okay, alkenes and alkanes. Why? This is what is the sp hybridized, this is sp2 hybridized, and this is sp hybridized. Okay, sp3 hybridized. That is why sp is more acidic, followed by sp2, and then followed by sp3. The hydrogens attached to sp3. Now let us compare on different alkynes. Now in different alkynes, if I compare, we have hydrogen, carbon, triple bond carbon, and hydrogen. Now if I have CH3, which is bonded to carbon and triple bond CH, then we have CH3 bonded to carbon, triply bonded to another carbon which is having CH3 group. Now obviously these two hydrogens are directly bonded to the CH, right? Directly bonded to, there are two acidic hydrogen, I can say acidic hydrogen, right? So this will be most acidic, followed by this. Why? Because here only have we only have one hydrogen, and this is the conjugate base here. It will not be much stable because this carbon atom will get a negative charge. It is bonded to sp hybridized, but again it is bonded to CH3. So CH3 will give electrons because it is plus I. Okay, because it is plus I. So the conjugate base will not be much stable. So this is going to be less acidic than the first one. Now this carbon is not at all acidic because it does not have any acidic hydrogen, right? It has one acidic hydrogen, and this has 0 acidic hydrogen. Okay, so is the acidic nature, is this clear with all of you? The two comparison of acidic strength.
Yes, sir.
What about others?
Clear, sir.
Okay. Now, next is alkenes. Since it has triple bond, so they will obviously show what? They will obviously show addition reactions, right? Addition reactions. Addition reactions. So since alkynes contain triple bond, they can add up. When we had alkenes, they added 1 mole of, right? So H2 was added. One H2 was added to alkenes. Now when you have alkynes which have two pi bonds, they will add up to 2 molecules of. We'll have first of all hydrogenation. Hydrogen, that means you can add H2 to it. Secondly, you will see halogenation. So you will add halogen to it, X2. Then we'll see some reaction of hydrohalogenation. So you will add hydrogen halide. That is HX. Okay. Then we will see a reaction with water. So you will have hydrolysis. So you'll have water. That means you're going to add H2O. So these are the 4 types which we'll see. So HH, this reagent is symmetrical or unsymmetrical, guys? Hydrogen is symmetrical reagent or unsymmetrical?
Symmetrical.
Symmetrical, right? All of you?
Symmetrical. Yes, sir.
Symmetrical, na? What about XX, X2? Symmetrical or unsymmetrical?
Symmetrical.
Symmetrical. What about others? Hamza, Hiba, Khalid?
Yes, sir, symmetrical.
Symmetrical. What about HX?
Symmetrical.
Symmetrical. And what about this water? H2O?
Unsymmetrical.
Yeah. This is also unsymmetrical. This is also unsymmetrical, right? This is also unsymmetrical. Okay. So these two, they will follow the Markovnikov's rule. So the negative part will attach on that carbon atom which has less number of hydrogen atoms. Okay, which has less number of hydrogen atoms. So OH and these two things, OH and X, it will attach on those carbon atoms which has less number of hydrogen. So I am giving you in all of them, there is one thing common. What is common? Hydrogen is common in 3 of them except the halogen. Okay, except the halogen. So what I'm going to do here, I'm going to give you a simple reaction C triple bond C, and there is let's just write H and Z. H and Z is there. So this Z can be anything. So first of all, what happens? First of all, this 2 will break and you will get H plus ion, right? You will get H plus ion. Then you are going to form, the hydrogen will be attached to any one of the carbon atoms and you will get a carbocation. You will get a carbocation. So if you are forming carbocation, the carbocation should be formed in the more substituted carbon. So forming carbocation. Then you have the Z plus. I'm sorry. You'll have Z minus, not Z plus. You'll have Z minus. The Z minus will attack on this carbon and you are going to get Z and you will get H here. Okay. Next, what will happen next? You can again form, you can again react this with HZ and you are going to form simple alkenes. Okay, simple alkenes. This is alkene with 1 mole. We'll again react this with HZ and you are going to get carbon, carbon, and depending on the carbon what is there, well, hydrogen, hydrogen, and Z and Z. Okay, so this is the general reaction. So let us first of all write hydrogenation, addition of H2. I don't think I have to write much here. I can just give you some questions. CH, triple bond CH. Now, if it reacts with H2 in the presence of PD, PT, or nickel, it will give me CH2 double bond CH2. If it further reacts with H2 in the presence of PD, PT, or nickel, it's going to give me CH3, CH3, right? CH3, CH3. Secondly, let us write. I don't have to explain much here, right? Yes or no? Let me give you one more reaction. CH3, CH3, C triple bond, CH plus H2. So first of all, you will get CH3, CH double bond CH2. Then you react this once more. Then you will get CH3, CH2, CH3. Okay. Second is addition of halogen. In addition of halogen, if you have CH3, C triple bond CH plus Br2, then first of all, I will be getting CH3, C, Br, double bond CH, Br. Then again, if I add Br2 to this, then I will be getting CH3, carbon. There will be Br here. There will be 1 Br here. With a single bond, carbon and hydrogen, there will be 2 Brs again. So we are adding 2 moles of Br also. We are adding 2 moles of Br. Now again, I must remind you guys that this Br2 is orange brown color, right? Yes or no? Brownish orange, which is used for the detection of multiple bonds. You remember this? Yes or no? We did this in the chemical properties of alkenes now.
Yes, sir.
Brown in color, है it is used for the detection of multiple bonds. Okay. Next is halogen is done. Next is if we add hydrogen halide. Okay. Hydrogen halide. So we have CS3, C triple bond, CH. Now, if I'm going to add HBr here, so tell me guys, Br will attach on which carbon? First carbon or the second carbon? Is my voice breaking, guys? Khalid, Salman?
No, sir.
No, okay. So tell me guys, HBr will attach on which carbon? Which has less hydrogen, na? So tell me which carbon? Br will attach on which carbon? First carbon or
First one.
second carbon? Br? First carbon, right? It will attach on the first carbon. So first of all, you will be getting CS3, C, Br, double bond, CH2. Then again, if I react this with HBr, then what I will be getting? I will be getting CS3. Again, the bromine will attach on that carbon which has less number of hydrogen, so it will attach on. Yes or no? Tell me. Any problem? Yes, guys. Any problem here?
No, sir.
Okay. Fourth. Addition of water. In addition of water, CS3, C triple bond, CH, reacting this with HOH. So what is the negative part in HOH? What is the negative part in HOH?
OH.
OH.
OH, very good. Double bond, CH2, yes or no? Correct? Right, guys?
Yes, sir.
Yes, sir.
Now you listen here, what happens? This is very important. Here we have double bond and then OH also. So there is lone pair here, which can take part in resonance. So I may draw a resonating structure like this. Right? And there will be bond going like this. So we have H3C, single bond, carbon. There will be double bond O. There will be hydrogen here. And you will have single bond, carbon, CH2, and there will be negative charge here. Yes or no? Tell me. Correct?
Yes, sir.
Okay. Now, what happens? This carbon atom and this hydrogen. You know that this hydrogen is bonded to oxygen, which is already having a positive charge. Oxygen is electronegative. When it gets positive charge, it becomes more electronegative, and it has the ability to pull more and more electron. That is why this delta, this hydrogen becomes very highly electron deficient. And here we have carbon atom, which is having electrons because it is negatively charged. So what happens? They react like this. And you form CS3, single bond, C double bond O, CS3. Okay. So this is very rapid. C double bond O हम वही ठीक से लिख देते हैं यहाँ पे C double bond O. Okay. Now this process doesn't happen like this. Like we don't find any intermediate like this. We directly see that there is a equilibrium like this here in these two. Both of them are present. So this is known as the enol, and this is known as the ketone. This is enol. That means there is OH group for all, and there is double bond. So this is enol, and this is ketone. So this is known as the enol keto tautomerism. When you have CH3, single bond C, OH, and double bond CH2. That means a carbon atom which is bonded to hydroxyl group and a double bond also, it can exist in a equilibrium. with the keto form in which you have CH3, C, double bond O, and there is a CH3 group here. There is a CH3 group for. So this is known as proton transfer. Proton transfer means this hydrogen, this hydrogen it transfer between the oxygen, that is OH, and the CH2 group. Right? There's a proton transfer reaction. That means it is an acid-base type of reaction. Acid-base type of reaction. So this is the product that you get. This is the product that you get when you add water. When you add water. Is this clear? Yes or no? This is known as. This is the enol form. This is the keto form.
So could you repeat this again? I got disconnected.
Okay, wait a second. Enol, keto, tautomerism. Okay, what about others? Khalid, Salman, Hiba, Hamza. You guys understood this? Yes or no?
Yes, sir. Understood.
Yes.
Understood, no? Okay, fine. So Shravya, you see, I have CH3, single bond, carbon with a triple bond, CH, and I have added water to it. Clear? Yes or no? Okay, now you tell me, which of this following, hydrogen and OH, which is negatively charged and which is the positive part of the reagent? Negative part and positive part, which is the negative part?
So your voice is breaking for me.
Okay, I can't help it then, na, Shravya.
So could you repeat again? I could not hear you.
See the screen.
Okay. OH is a negative part.
Okay. It means OH. Attach. On which carbon? Yes, Shravya, tell me. Yes, correct. Okay. Till here this is fine. Yes or no, Shravya?
Yes, sir.
You can hear me now?
Yes, sir.
Okay. Can you see resonance? A double bond B, single bond C, and C has a lone pair.
Yes,
Can you
sir.
see resonance? Okay.
Yes, sir.
Yes, correct. Oxygen will get a positive
Yes.
charge. Okay. This hydrogen will be very electron deficient, electron poor, because it is attached with oxygen, which is having a positive charge. So this oxygen will be pulling all the electrons. Yes or no?
Yes, sir.
This carbon is going to be electron rich because it has negative charge.
Yes, sir.
So an attack can happen from electron poor to electron rich, and you will be getting. Got it?
Yes, sir.
Okay. But this, it doesn't happen in this 3 steps. Okay. It happens so rapidly that it is seen as a proton exchange between the enol form. This is the enol because this carbon, it is bonded to double bond, that means ene, and also OH, that means all. And this is the ketone form. This is the ketone. So we have CH3, single bond, C double bond, sorry, COH, pi bond, and there is a CH2. So these are in equilibrium because this is a type of acid-base reaction. Okay, because it is not, please remember, it is not resonance, and it is, you can say that it is mediated by resonance, but these are not resonating structures. These are different structures altogether, which are present due to reaction. That means breaking of bond and making of bonds, right? So we have double bond, and here we have CH2. Then you get CS3, single bond, C double bond O, and CS3. So there is a proton transfer between the CH2 and the oxygen atom, and this type of equilibrium. Now both of these are present. Okay, don't say that only this is present or only this is present. Both of these are present, and you get, this is known as keto enol tautomerism. Okay, so you get this, yes or no? Please tell me.
Clear, sir.
Okay, now, so we can say the the carbon which has less number of hydrogen gets the double bond O. It forms ketone. So if I have something like this, CH3, CH2, single bond C, and let us say C triple bond CH3. So in the presence of water, CH3, CH2, C double bond O, and you will get CH. So this will not CH3, this will be CH3. Okay. So the less substituted carbon atom will be getting the carbonyl carbon double bond O. That means less number of hydrogen atom. The carbon which has less number of hydrogen atom will be converted to ketone by the addition of water. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay, fine. So that is it for today. Just write a note here. Addition of water is done. In the presence of Ng2 plus and H plus. Okay, so if you see mercury and all, don't get confused. Okay, it is addition of water only, reaction of water only. Okay, so I started today's class with polymerization, and I am ending this also with polymerization. But this polymerization is for alkynes, है ना? तो alkene के polymerization से लेके alkyne के polymerization तक आप लोग को लिखना है ना? This also you have to write from NCERT. Is that clear? Yes or no? Hamza,
Yes, sir.
Hiba, Khalid.